Now, it was about a year ago that I bought this very cheap LED spotlight, and when I took it apart I noticed that it had a mains dropper circuit, no transformer, so the mains was passing through the bridge rectifier and straight into the LEDs on the front plate, and the LEDs have there's no cover on this thing, so you can actually touch these essentially live connections. The only thing separating them from you and the mains is the diode in that bridge rectifier. So I was a bit put off these LED spotlights, so it's quite nice to have been sent something of real quality. Now this is the Alt LED V7 GU10 LED spotlight, and this was sent to me by EnergySavingLED.com, and the image on the V7 page shows it has Cree LEDs. It's £29.98, and there are some other images here, and if you click on these you can see that it has 4 of these little Cree XTE LEDs. Now I'm interested in how safe this thing is, and certainly if you look at the label on the side you've got a whole bunch of accreditations and compliance indicators. We've got CE down the bottom there, FCC, the TIC, and also UL. Now I didn't know what the TIC and UL were, so I looked them up. So I found this page on the National Instruments website which explains what all these certifications and standards are. CE, European Union EMC Safety, FCC, North American EMI, RCM, or the TIC, is Australia New Zealand EMC, and then coming a bit further down you've got UL, North American Product Safety. So they explain what they all are in more detail here. But I was interested in the UL one, and the website for UL is ul.com, and I was just interested to see that on the What We Do page it actually has a picture of an LED spotlight. So let's switch this thing on. There's a short delay before it comes on. Now what I tend to do these days is if there's anything with mains I will just sort of flick it like that, so that if it is live I don't get mains for too long, but this thing's fine. I'm quite happy to hold that. Okay, so let's have a look. Looks reasonably bright, but what I need to do is a comparison with a halogen, so I'll do that now. Now one thing you do notice if I shine it at a white door is that it's bluer in the centre of the beam and then goes yellower towards the edges, but that's fairly typical of warm white LEDs. I've seen that a number of times before. Now I only have a 35 watt halogen, so the comparison isn't entirely fair, but here we go. That's the 35 watt halogen, and there's the 7 watt LED. So 35 watt halogen, and the 7 watt LED is very bright. It's not a very fair test to do on a camera like this because it will auto gain and change the brightness setting. It's almost impossible to do a proper comparison, but I can tell you that it's very bright. It's certainly the equivalent of a 50 watt halogen, so I'm happy with that. And after that brief test the heatsink is now warm, and that's a good sign because that means that the heat is being drawn out of the LEDs and moved into the heatsink, and that's precisely what's meant to happen, to move the heat away. So now the part that I was looking forward to most, which is taking this thing apart. And I have full authorization from Chris at EnergySavingLED.com that if I need to, I can destroy this thing. I don't want to because it'd be quite nice in my kitchen, but anyway, here goes. So it's a relatively easy thing to get the bezel and the lens off, and now we have inside the board containing the 4 Cree LEDs, and I'm going to try and lift that out. So I've lifted the board a little way up, and you can see underneath it there's some thermal paste. Now it might be a thermal grease, or it might possibly be a thermal adhesive which hasn't set yet. It's hard to tell. But there's that sort of cup that the whole thing sits in the centre of the lamp. And I need to try and get that out, and it looks like it's going to be quite difficult. But there are some threaded holes there, so I'm going to try and find a couple of screws to put into those threaded holes and see if I can lift this receptacle out. So I found a couple of bolts which fit into the threads on this little cup thing, but this is where this might get ugly. I might need to use the big pliers. Well, now what happened when I pulled reasonably hard is that the heatsink part came off the plastic base, and what you can see inside is that the whole thing is potted in what looks like hot glue, so that's not coming out. But there are a couple of things you can see here. One is what looks like an electrolytic capacitor here, and that sits up inside the hole in the bottom of the heatsink. So that capacitor is actually going to get quite hot. Now the other thing you can see is that there is a transformer. I'll see if I can point it out. There it is with the yellow coating and the wires emerging out and running back down onto the circuit board. So this thing is transformer isolated. I can't possibly find out what the circuit is, but that is the essential safety element for a mains powered LED lamp. So I'm reasonably happy, but I'm just going to see if I can peel the label off that, what looks like a capacitor, to see if it actually is a capacitor. And you can see that it is indeed an electrolytic capacitor. It's a 330 microfarads, 16 volt. A little bit surprised that it's poked up inside the hole in the heatsink, because it is going to get quite warm, and electrolytics are prone to drying out when they get warm. But I guess the guarantees and warranties, lifespan 30,000 hours, would kick in under those conditions. So, well, now of course I've taken the insulation off that thing. I've got to be careful it doesn't touch the heatsink, so I might need to just put a little bit of sticky tape over the top of it. So that's the Alt LED V7 7-watt LED spotlight, which in the UK you can get from energysavingled.com. And as you can see, it's still working even after I ripped it to pieces. So that's going in my kitchen. Ah, yeah, that looks pretty good. There it is, the one on the end there, and that lights up the cooker very nicely. So, thank you very much, energysavingled.com.